Good evening, everyone. We're here now for the Birds of a Feather for the evening session to end the first great day of the CENIC conference. So Dave Reese with CENIC, and for our panel this evening we have one substitution. Internet2 withdrew from the panel. We'll have Jen Leisure from the Quilt taking their place to talk about what the Quilt does in national networking in the United States. So we have a great panel tonight. We have Jen Leisure from the Quilt, and then we'll have Kurt Snodgrass from National Lambda Rail, and then Michael Sinatra with the ESnet. We'll do questions at the end for the panelists, so if you hold off till the end on questions, we'll have three of them take questions at the end. So with that, I'd like to remind everybody as you come in, there are refreshments in the back room. Please enjoy, and we'll start off with Jen Leisure from the Quilt. Jen?
Thanks, Dave. Thank you for having me join the panel. It's a pleasure to be here at the CENIC conference. I appreciate all the presentations from today. What a fantastic set of presenters and information. So thank you for all the information that I was able to gain today by attending. I wanted to provide some information about the Quilt. The Quilt is a consortium of regional networks across the country. So other regional networks like CENIC here in California come together in the Quilt. And as a consortium of regional networks, we have 4 areas that we come together, 4 strategic areas that we come together to work on. First, the Quilt aims to be a trusted forum where representatives of these different regional networks come, share their ideas, share their experiences with one another, and through that collectively advance research and education networking for our country. The second is for the Quilt to advocate for regional networks as key partners to higher education, key partners to some of our national partners like National Science Foundation, and through its program with Genie, with the NOAA initiative and NWAVE, and so those national partnerships to be a key point of contact for those types of organizations to come and communicate to the regional networks. The third goal that we have is to convene the forums where our members come together and to share ideas. And this happens at different levels within our member organizations. So we create forums where our executives come together, where the financial representatives can come together and share information, where communication and outreach resources within these regional networks come together. And so it's really to convene forums for these folks to come and specifically talk about their roles, responsibilities for a little more focus. And then also we aim to be a resource for our members to inform them on topics of interest. RE networks operate in a very complex landscape, as you know, and to stay on top of all the different pieces of information that you need to out there. We rely heavily on one another to help be a knowledge base to support each other's efforts. So the Quilt is and we've heard it several times throughout the conference today, a member-led and a member-powered organization. We have a very small staff, and with that, I think that is one of the advantages for our organization in that we lay out annually a set of priorities, but we're also able to have the flexibility to shift when new things come up in our landscape with our members that we need to address as a national consortium. We have 31 members that are regional networks, and when I use the term regional networks, a region can be a portion of a state where aggregation happens among the higher ed institutions and some of the other community anchor institutions. A region can be a state, or a region can be a multi-state collaboration, and we have Quilt members that have organizations that span all 3 of those different definitions. About a third of our members are incorporated as not-for-profits, such as CENIC is. So they're standalone independent 501c3s. About another 40% of them are organizations that are university-based, that they're housed in a university and are managed through that university. And about another 25% or so are divisions of a state department. So for instance, the State Department of Education or some other state governmental entity. that houses them. Throughout the regional networks, different models also serve a broad set of community anchor institutions. Each of them have member institutions and organizations that they serve, which are really defined by the missions of those organizations, the history of those organizations. And so certainly within the Quilt membership, we all have very similar missions to support research and education. But the flavor that takes in terms of some of the institutions that the regional networks are able to serve within their geographic area, that takes on different faces as you move throughout the country. At a high level, and you heard some of this today with the regional network panel, Front Range Gigapop, the University of New Mexico, and the Albuquerque Gigapop, CENIC, and we heard it all with our also with our international partners. But some of the priorities across these organizations and across the country, we have many of our Quilt members that are involved with the BTOP projects. And so the role within a BTOP project, some of them are direct awardees, some are subrecipients, some are supporting the efforts in their state. And I think almost all of those are wrapped up, intended to wrap up this year in 2013. So there's a push for completion there. We've had ongoing conversations within the Quilt, sharing experiences with these projects, sharing ideas, and we've had that going on since the start of the program 3 years ago. Push for 100 gig networks is certainly at the top of priority list for many of the regional networks, and that was a theme that we heard today in the conference. We've got many of our Quilt members also connecting to state telehealth networks. So healthcare and telehealth is a priority for these organizations. And then also the suite of value-added services. So not just the network, but the services that can run on the network, that we can leverage the infrastructure that's been invested in by these institutions and cost effectively and efficiently deliver a suite of value-added services to the institutions that each of the regional networks serve. One of the priorities that we've had within the Quilt members is to exchange ideas about what types of services are being offered, how they're delivered, share interests, mutual interests in service providers, but to really leverage one another's experience and expertise in providing these services. We've put together information to where regional networks are able to provide services to other regional networks so they can help bring services to their institutions faster. We try to capture that information and share that. And we also have been collecting data on the broad suite of services that across the country the regional networks provide to their institutions. It's really a breadth and wealth of services beyond network connectivity that are supported with these regional networks. So we've got some different models and certainly some different types of organizations within the Quilt. It's really the diversity of the organizations that bring the rich conversations to our Quilt forums. It's very interesting to learn from similar organizations, and sometimes even more interesting to learn from those that are different, where you can get some new ideas and some new insight into advanced networking. I'll take a few minutes to talk about some of our recent and current projects to give you a flavor of the work that the Quilt has been doing recently. In the past year, we've been focusing on strategic communications, trying to help and encourage our members to develop a communication plan. Many of our members have small staff and small staff that are technically focused and don't have the resources to dedicate to communication and outreach. And in the last year, we've put a priority on helping our members understand that communication outreach doesn't have to take a lot of resources, but utilizing the tools that you have, utilizing your website, capturing your institution stories and how they're using the network. CENIC does this very well with showcasing all the different uses and collaborations that come out of the network, and encouraging our other Quilt members to spend time in documenting those member stories and success stories and putting them into terms that they can share with folks outside of technology. And so that's been an area of focus for us this year. every year, along the lines of strategic communication, in the last 3 years, we've put out a publication called the Quilt Circle. And it's available online on our Quilt website. We're working on our 2013 edition right now. But this is a compilation or a catalog of each of our members showcasing one of the projects or one of the collaborations that was facilitated by their organization. And certainly these stories are very powerful on their own. But when you put them into a national catalog, it really tells a great story for U.S. R&E networking. And so we should have our 2013 edition out here in the next month. So look for an update on our website when that becomes available. The Quilt also has a history of pulling together consortium buying opportunities in negotiating contracts where we think our members, we can aggregate and collectively gain efficiencies in negotiating the contracts. One that we just took on last year was an OpenFlow enabled switch RFP. And we'd like to thank CENIC for its contributions to helping us complete that RFP effort. Out of that effort, we signed contracts with 5 switch providers. And so these folks are also up on our website, and a list of authorized quilt buyers allows you to access some of the discounts from these different switch providers for their OpenFlow enabled equipment. So we are also holding a series of webinars that just started in the beginning of 2013. We're asking each of these OpenFlow switch providers to come in and talk about the technology for about an hour, and we'll have the schedule up on our website as well for the next ones. Archives from the last 2 are available publicly if you have any interest for those. We had HP Networking recently, and also Pika 8 do webinars, and we have some upcoming ones this spring, so we'll keep you posted on those. But these have been popular, and it's a great way to get additional information about OpenFlow. The other service that we started in the last couple of years, which I think really showcases the amount of collaboration and peer support that happens within the Quilt, is what we call a Quilt peer review project. And this came out of an idea a few years ago where Quilt members were going to outside consultants, big consulting firms, and asking them to come in and do a business review. And they were spending a lot of money on an hourly basis to teach folks what R&E networking was about and get reports that didn't necessarily tie to the missions and what they were trying to accomplish. And we thought, well, who better to help come in and provide some external insight for folks that do know R&E networking and can bring in a different perspective. So we asked for volunteers of leaders within our Quilt community, other regional networks, to volunteer and help support peer reviews. These are often requested by an advisory board or some type of governance of an organization with a particular scope that they'd like to get some feedback on, some candid feedback from some others that know our community and know the work that we do very well. And so we've undertaken about a handful of these now over the last few years, and I think that that's been a very successful program. We're just completing one now, and we've got another one slated to start this spring. So I'm really excited about that particular project. And so Dave's been giving me the sign that I'm slowing down on time, but I think we're going to take questions at the end if there are any. Great, thank you.
Once they finish debugging all the video, it'll look like I know what I'm doing when I go up there. So I'm all happy about this.
Good about going last,
Yeah.
right? Yeah.
We can go ahead and go without it. That's all right, we'll just go without it. That's all right. And I had some really cool slides I was going to show you guys. It gets better with every beer. Like Jen, I'd like to extend our appreciation from NLR to CENIC and Lewis and the CENIC board for inviting us here to participate today in the Birds of a Feather session. I'm not going to go into a great deal of detail on the history of NLR and what it is. I assume most of you are intimately familiar. So my goal today is to mainly discuss, from last year's session, Bonnie Hurst on our staff came out and presented to the group kind of the operational update of NLR. And my goal today is to kind of take that into throughout 2012 and into the early part of 2013. I do want to make a note here that the main goal, operational goal of NLR is to continue to support the R&D needs of those RONs and institutions throughout the U.S. In the recent year and a half, we have added additional capabilities and applications such as genomics, proteomics, and other healthcare delivery applications. And I'll warn you right now, in the Q&A session, if you ask me anything about proteomics, I'm just going to glaze over. I'll probably just go get a beer. But with that, with the introduction of all of these healthcare and advanced applications, we are working on developing a sustainable business model that can provide the level of connectivity and network services that we're committed to the previous members of the NLR, the Class B members, going forward for the next 10 years, but also monetize some of these applications to reinvest back into the network for upgrades and services. Another key component is NLR's reliance in recognition of the importance of the regional optical networks. Patrick Soon-Shiong, has made a commitment not only to sustain the network going forward, but also partnering with the regional optical networks in delivering a lot of the advanced healthcare applications that he envisions into the near future. We can get it so far with the RONs, but then we've got to get it down to point of care, down to the clinician level, down to the doctor's office level. And that's where these commercial partnerships, you might have seen some recent press releases from Verizon and AT&T. That's the intent of those relationships, is to really move his vision for transformative healthcare down to the patient, the clinical level. And then ultimately, the goal is to transform healthcare delivery in the U.S. I used to work in the Medicaid program in Oklahoma years back, and we had a board member, physician back then in the mid-1990s said healthcare is a functional fiefdom. And Dr. Soon-Shiong is trying to tear down those barriers. And from treatment to point of care to payer, make it a systemic evidence-based delivery model that is delivered by technology, that's delivered by NLR, by CENIC, by Front Range Gigapop, by New Mexico, down to the patient point of care. So a couple of the biggest things that happened since we were before you last year is in May of 2012, CENIC and NLR announced
the transfer and the migration of our NOC services from the University of Indiana to CENIC. It was an arduous task, and I'm looking at a lot of familiar faces here in the audience that were very instrumental and helpful in making that transition happen. The leadership of Dave Reese, Sherilyn, Lewis, we had like a 60-day window to move everything from Indiana to CENIC, and they've done a remarkable job. That's probably one of the biggest efforts that were underway in 2012 as we move forward. And we also look forward to partnering with CENIC in developing additional and enhanced tool sets. That's one thing that we've had multiple conversations on, and we're committed to making that happen to give us all a better view into the network and the services, availability, reliability, those types of metrics. And then concurrent with the migration to CENIC from IU of the NOC services, we moved the telepresence management from Indiana University to University of Wisconsin-Whitewater. The individual there, Nick Chazinski, has done a great job in making that transition happen and managing a lot of the technical components that go along with telepresence delivery. Our services, high-speed connectivity throughout the U.S. within the R&E communities, and now more recently in the healthcare communities, that's a mainstay. What we're starting to see, though, is with regard to delivering some of these advanced applications and genomics and proteomics sequencing, it's not only delivering the bandwidth, but also working behind the scenes to make sure that all of those connections are HIPAA compliant. I don't have anything to do with that. It kind of happens behind the curtain in LA in Dr. Soon Chong's office. But that is one thing that is paramount to him, is that any service that we provide will be HIPAA compliant. We're still managing the telepresence exchange, the NLR exchange. We anticipate providing that for years to come. That's an application that was probably one of the first applications that rode over the NLR backbone, and hundreds of institutions and endpoints are connected to it, and so we're committed to continuing that. Some of the new services, as I alluded to in terms of the genomics and proteomics research, is data storage, computational capabilities at some of the facilities that we've developed in Phoenix. Those are kind of brand new, not beta, but just off the shelf. We are working with the John Wayne Medical Center, or John Wayne Cancer Research Institute, in St. John's, in connecting them into the core network and delivering to them genomics and proteomics sequencing. And it's through a partnership that Dr. Soon Chong has with 5.3 Genomics that provides the GUI front end that these researchers and physicians can actually push and pull that data and get the information that they need for better evidence-based cancer treatment. Jen had mentioned OpenFlow. Many of you are aware we have 5 OpenFlow switches on the network, HP ProCurbs. We've been working with GPO, and we're going to continue to support that initiative. And we've recently worked with them to make the determination to add 3 additional switches on the network. They will be Pronto 3780 switches that will integrate in El Paso, Houston, and Kansas City. So we will now have 2 north-south paths on the network for the OpenFlow engineers. And we anticipate getting El Paso deployed in the first quarter of this year, so it's going to be kind of busy. Looking at expanding our capabilities, as you're aware, we're a 10G network. The vast amount of capital that Dr. Soon Chong, or his Institute for Advanced Health, and the National Coalition for Healthcare Integration invested into the network is seen as an opportunity for us to make that migration to 100 gig. We have been having multiple meetings with various vendors and providers in recent months, looking at what will be the best solution, not only from a technical standpoint, but also a business standpoint, in meeting the various needs of the R&E community, as well as delivering healthcare services. I referenced Phoenix. And that is an area where we have facilities at the IO data center. Dr. Soon Chong and his staff at NantWorks have racked a myriad of supercomputers there, as well as storage devices for the genomics and proteomics storage and transfer. And all of that is delivered over what we refer to as the Cancer Knowledge Action Network. I wish you could see these slides. They're pretty illustrative. What we call CCAN is a 10 gig national ring that is exclusive to healthcare research, healthcare delivery. And we were able to work with St. John's and AT&T to bring them into our POP in Sunnyvale, and then ultimately transport them over CCAN to Phoenix. And it's our goal and our expectation that more and more of these applications that are being developed by Dr. Soon Chong and NantWorks will continue to ride this national backbone. And that has been one of our major efforts over the past year. The stack, the CCAN stack, we're looking at, the network layer. We're looking at applications as a service, software as a service, platform as a service. All of these things that will be developed and made available to individual research hospitals and clinicians in the RONs. We're looking, Dr. Soon Chong has a commitment to the RONs going forward to partner with them to see if there are needs or demands within the constituencies like CENIC serves that could be benefited or assisted by some of the research that Dr. Soon Chong's doing in LA. It's an exciting time. We look forward to growing our applications and our services with CENIC, and I guess I'll entertain any questions at the end.
See if I can make as much noise as possible doing this.
You're right, those are good-looking slides.
So I've got some great slides to show, but I don't think I'm going to bother. I'll describe them to you instead, because you can kind of guess what some of them are going to look like. Can I do this also? Is this working? This way Chris won't have to go run around with the microphone. I'll run around afterward. I'll be the Phil Donahue. Well, I can't even get it to work now anyway. Okay, so how many people here do not know what ESnet is? Be honest, everyone knows what ESnet is. Who funds ESnet? Who provides the funding for ESnet? DOE. Specifically, who in DOE? Is the Office of Science funds ESnet. That is the largest funder of scientific research and science in the United States, and we are their network. So ESnet is now entering its 28th year as the network for science in the United States. So let me bring my slides up here so I can show them to you.
Ta-da.
So that's what we are. That is our role. We connect the national labs, the science labs in the United States, and our goal is to provide the best network we possibly can and to accelerate science, and more importantly, to make the network an extension of the scientific instrument. So we are a relatively small group of people running a relatively large network. We have a national network, a national footprint, and we are a group of about technically 40 people. I think we've only had about 38 working for us right now because there have been retirements and we haven't been able to rehire everyone. One of our big concerns and one of the things we like to do is partnerships and outreach. So you're going to find, as I go through this talk, and as you can see from the slides, you're going to find a lot of references to our partners. The partners we have sitting right here, the partners we have in the audience, like CENIC and all of you, and also Internet2, who isn't here today. But it's worth noting that we have been partners with NLR. We are members of the Quilt, so we have been involved in those initiatives for quite some time. And I think many of you know Steve Cotter, who used to be the head of ESnet, also helped to build NLR. So there's a lot of overlap between what we do and what all of you do, and partnerships are very important to us. It's also very important for us to be involved in the community. We are part of the R&E community, and that's extremely important that we continue to make that one big community that feeds on itself and that cross-pollinates. It means that we can do better not only in our own areas, us connecting the national labs, you guys connecting the universities in California, these folks connecting the universities across the country, but we can do better in collaborations among our networks. So that's also very important to us. So what happened in 2012? We should talk a little bit about our highlights of the year, because Greg Bell was here last year talking about that. So one of the things we did is we built a 100 gig production network. Now, we already had a 100 gig network. It was a prototype network that was part of an ERA grant that was basically designed to say that if you actually build a 100 gig network, can you do science at 100 gig? Can you actually make a difference in science? And the answer we were able to come up with was yes. And in fact, I have a great slide here that shows an example. As you can see, there are two different views of the formation of the universe. On the left is the view of the formation of the universe at 10 gig, and on the right is the formation of the universe at 100 gig. Now, what's cool about this is you can hardly tell from the slide. But what we were able to do is we were able to do a 3D modeling in real-time visualization. So we had a supercomputer over at NERSC, and we had which is in Oakland, by the way, in Oakland, California, and we had a visualization station at the supercomputing conference, which was in Seattle. We were able to do 100 gig real-time visualization of the start of the universe. Why is that important? Well, what's interesting from an astrophysicist standpoint is when the universe was formed, it was extremely homogeneous. And as the universe expanded and cooled, it became much more heterogeneous. Different particles formed, different building blocks formed, and they created different types of atoms and molecules and all that stuff and structures and things. If you can visualize that in real time, and you can get the more detailed visualization than you could get with 10 gig, with 100 gig, then there's a real benefit to going to 100 gig. And that's just one example of one of the things we were trying to do. So having sort of figured out that we can really do good science at 100 gig, we decided, let's make this our production network. I mean, that was part of the grant anyway, was to make it part of the production network. So what we needed to do is take a network that was really two networks. They were using different vendor platforms. They were even using different IGP protocols. They were peering with each other over eBGP, so they weren't really connected in any other way. They were peering with each other like we might peer with NLR or CENIC. And they also had very different CLIs and other models like that. So we had to basically redo our tools. We had to merge the IGP. We had to merge the network. And the slide that I have right now is this very complicated decision tree about how we merged our IGPs. So it just gives you an idea of the complications of the process that we went through to build out the new networks. Now, no national NREN network talk would be complete without the map. So here's the map. This is and you know what? You don't need the slide because you know what it looks like. It's a map of the United States. You know what that looks like. And it's got a bunch of links going across it like this, like a basket across the US. Those are 100 gig links. So we have 100 gig links going all the way across the United States, and basically two sets of 100 gig backbones going across the United States. And then we have metro area networks in the Bay Area, and we have them in Chicago, Washington, D.C., the Oak Ridge area, and the New York City area, right around Long Island where we have Brookhaven National Lab. And we have dark fiber, redundant, diverse path dark fiber going up there. Everywhere except Washington, D.C., we have 100 gig now going into place. So our sites are now connecting to us at 100 gig as well. And that's what we're going to do over the next few months. We're doing that now. Building up our peerings. Our peering to CENIC is going to go to 100 gig any minute now. Our peering to PacWave eventually will go to 100 gig. And our peering to MANLAN, which means Internet2, we will have 100 gig peerings there. So we're going to have a number of 100 gig peerings. We're also going to have a number of 100 gig to our sites. And they're all the whole alphabet soup of the national labs: ANL, BNL, FNAL, LBNL, LLNL, NERSC, and ORNL. NERSC and LBNL, those of you who are observant know that that's part of the same site organizationally, but we treat them as separate network sites because they actually have a lot of traffic. Okay, what else have we been doing? Our staff have been involved in a lot of different things, but one of the things we've done that I'll just highlight here is continuing to develop the Oscars software. Oscars was early SDN before it was called SDN. It was an example of SDN. In fact, we actually did call it SDN, but the acronym meant something else. It was Science Data Network, not Software Defined Network. But Oscars allows you to reserve bandwidth, build virtual circuits across the ESnet network, and we have a lot of virtual circuits that have been built and maintained as a result of that. This was also the year that the Science DMZ concept really took off. Many of you probably know what the Science DMZ is, because especially if you look at the presentation tomorrow on CCNIE, which is the NSF grant that's being given out to universities to build up their network infrastructure for the purpose of scientific research. That Science DMZ is specifically called out in the CCNIE grant. Now, ESnet didn't invent the Science DMZ. A lot of people out there say, well, we were doing Science DMZ before you even called it a Science DMZ. And that's right. That's why we decided to call it a Science DMZ. You guys were doing it, and it was working. And we saw these models out there. We saw these different things out there that people were doing that were working for high-speed, high-volume data transfers. So we generalized that model and codified it, and that's how we created the Science DMZ. It's really just a concept that we did based on a generalization of what folks like you were doing out there. So if you're interested in the Science DMZ or in the CCNIE, the proposals are due April 3rd, and we can certainly talk some more about that, but I would also encourage you to pay attention to the presentation tomorrow that's going to be on CCNIE as well. The other thing that ESnet has done is we've continued to build up and make robust our test beds. We have a number of test beds, a 100 gig test bed, we have a dark fiber test bed. The nationwide network map that I showed you not only has 44 waves, which we share with Internet2, so there's 88 waves total. Internet2 gets 44 of them. We get 44 of them. That's part of our big partnership with Internet2. So we have the potential of having 4,400 gig waves on our existing footprint. We also have a dark fiber footprint across the exact same mileage footprint. That means that we can hook up additional wave gear to that dark fiber, and we can put 88 waves across that fiber. So I'll talk about that in just a few minutes. But we are able to use that right now, because we have the other waves, we're able to use that right now as a dark fiber test bed. And we have vendors and partners who are interested in doing some interesting research and tests on that dark fiber test bed. We also have a 100 gig test bed, and the 100 gig test bed has basically interconnection points and points of presence at places like Starlight and MANLAN and some other areas where you can connect to it. And the test beds are open to everyone, basically. You might think you need to be part of DOE or you need to be collaborating with DOE. We actually get people from industry to use the test beds. We get people from EDUs. We get people from government agencies as well. And what's really cool about it is you have access to the entire network and to the systems that are on it. You can actually put your own operating system on it. You can pixie boot we have a bunch of data transfer nodes, high speed, high capacity data transfer nodes, and you can actually pixie boot them if you want to. And you can run Plan 9. You can build your own 100 gig Plan 9 network if you want to do that. So there's a lot of interesting stuff you can do. And I have these really cool pie charts which actually show that only about half of the funding comes from DOE for the test bed research. The only people, by the way, who don't like the test beds are those of us in the engineering group, because we have like 3 or 4 different test beds that are all called Testbed. So when somebody says there's a link in the test bed that's down, everyone's like, well, which test bed are you talking about? One of the other things we're doing that's kind of interesting with the test bed is a layer 1 OpenFlow test. So we're actually trying to figure out, can you apply SDN and OpenFlow as a protocol to a layer 1 provisioning network? We're working with Infinera to actually build out a provisionable, programmable layer 1 network that allows you to take multiple independent physical links and build waves across those at certain bandwidths. So you can have controlled bandwidth, you can have controlled latency, depending on which link you go across, and you can have failover as well. And you can change on the fly using OpenFlow. And so far we're moving along with that process, but we've actually been able to do some pretty successful demos. And I think this stuff is actually very interesting, what we're working on here. Oh, and this slide is animated too. I mean, what more could you want? So that's what we've done this year. I'm going to very briefly talk about where we're going. There's a lot of stuff happening in the internet. We all know about IPv6. We know about things like DNSSEC. There's also a new effort to secure the routing portion of the internet, RPKI and BGPsec. We're not there yet in any of these things. We haven't finished deploying IPv6. We haven't finished deploying DNSSEC. We haven't even started deploying, in most cases, anything about routing security. So we're going to be very interested in how that sort of thing plays out over the next few years. And that's going to be pretty important to ESnet to continue to be kind of we'll try it first and see what happens, and let our sites then move into a somewhat more known territory when they're deploying new technologies like the ones I just mentioned. But the other thing that's really big and important to us is bandwidth, because there just still isn't enough. Even though we have a 100 gig network, even though we have the potential to use 88 waves of 100 gig, there still isn't enough bandwidth. I'm going to show you a bunch of graphs now, and you know exactly what I'm going to do here. You can imagine what graph is going to be up there. The first one is a logarithmic scale of the amount of traffic accepted by ESnet, transferred by ESnet. Okay, so it's a logarithmic scale, and starts in 1990 and ends right at January 2013. What does the graph look like? Guess what? It's going to be up and to the right, isn't it? All right, great. I have another graph of the data growth of the LHC Atlas project. So it's now up to about 120 petabytes, and guess what? It's up and to the right. I have another graph that is a bunch of slopes of data growth in different sectors. So it includes the financial sector, the science sector. So these are, of course, all up and to the right, but the second steepest one is the science. Science data is rising the second steepest rate. The steepest rate is the New York Stock Exchange itself. That part of the financial sector is the steepest rate of growth right now. That information was compiled by the IEEE, and they used it in a lot of their presentations. They used ESnet as a model for the data growth in science. And they're trying to figure out, where do we go next? So do we go to terabit networking, or do we go to 400 gig next? And the answer is probably we're going to go to 400 gig and not right to terabit, which is interesting because if you look at where ESnet is right now, I have another set of graphs, all of which go up and to the right. But it really sort of shows, this is an interesting graph that Joe Metzger did, which shows kind of where we've been, the amount of bandwidth we could offer to into the networks, basically bisectional bandwidth. So the amount of bandwidth we could offer into that bisectional connection in the network versus what the demand was across that network. And we've always been a little bit ahead of the curve. They're both lines going up and to the right, but we've always been a little bit ahead. And so the next question is, how do we project out from the current part out to where we're going to go in the next few years? And we get out to about 2020, and we've used up all of our waves, all of them running 100 gig. So in about 6, 7 years, we're like basically maxing out our optical network at that point. Then we need to go to something else. We're going to need to go to 400 gig or terabit or something like that. And so I think there's a lot of people who talk about the data, but it's really nice to talk to some of the researchers. And if you ever for those of you in the program committee, there's a guy named Sandy McDonald at, I think he's at NOAA or NCAR, one of those places. Noah Boulder, thank you. The NCAR, the other NCAR person told me. So yes, Noah Boulder. He talked at an N-Wave meeting a couple of years ago about Earth system modeling. This is doing major modeling of the entire Earth system, the entire Earth atmosphere. And he was talking about the sort of holy grail we talked about earlier today is resolution. Can you get to lower and lower or higher and higher resolutions of Earth modeling? And so, 100 meters by 100 meters horizontal is like one of the most ideal ones you can get. And if you actually try to do a 10-day prediction of the entire Earth climate at a resolution like that, you generate 6 times 10 to the 19th bytes. Okay? Just to do the math really quickly, that would take 14 years to transfer that entire data set from Japan to the US, assuming a 1 terabit per second network that's actually transmitting at 1 terabits per second. Okay, we don't even have a 1 terabit per second. It takes 14 years to do that. And that's for a 10-day prediction. So that's not going to work. We need to keep moving, obviously. But we don't know how quickly we're going to be able to move and how far we're going to be able to move. When are we going to start bumping our head against Mr. Shannon? So that's a big question that we have still. And that's one of the things that we're going to continue to push. We actually have my boss, Mike Bennett, is involved in the IEEE, so he's involved in a lot of the Ethernet portions of the IEEE. And we also have people who are working on a lot of the OpenFlow and SDN, especially this layer 1 switching, which might allow us to multiplex against different layer 1 networks. But we also want to partner with you. Why is that important? You have researchers, and they're collaborating with our researchers. And it's important that we make sure that those collaborations can happen the most efficient and effective way possible, that everyone's getting their money's worth out of the collaborations. I talk to CIOs and CTO types, and they say things like, we don't have any demand for more bandwidth on our campus. And I said, really? Do you know that there are researchers who are shipping disk arrays across the country? Do you know that there are graduate students who are flying across the state to go manage servers that are in a different data center because they can't transfer the data back to campus where they want to manage it? It's important that we continue to make it clear that yes, there are researchers on campuses that need to do things, and we can get people in the central IT divisions and in the networking divisions working with those researchers. Everyone wants to collaborate. Everyone wants to do it. We just need to basically get the people put together. There's a disconnect that we need to push together and make work. So that's why we're interested in partnering with all of you and with CENIC and the folks on stage and Internet2 as well, even though they're not here. And we're in the future, we're helping campuses with CCNIE proposals. And if you're interested in that kind of stuff, you're interested in talking about research collaborations with DOE, please talk to me. Thanks.
Thank you. So now we get to the Q&A, and do those microphones actually work so you can
I haven't tested it.
stay seated? So I thought I'd kick it off, and for Michael's benefit, I've got my questions up here on the screen. So with that, I think I can just pass it off and let him in. But actually, he was straight man for me and let in. I'd like to ask each of the panelists to think out 1 to 3 years, and with how you're currently working with CENIC, what could you see? How could you see us working? How can we improve our relationship with your organization? And I guess, Jen, you can either talk about the Quilt or the regionals. Take your pick. But I'd like to ask each of you to just kind of think, what would you see, and how could you see you're working differently with CENIC than we do today?
All right. I'll take a shot at this first. I don't see us working differently than we do with CENIC today. Well, the scale will certainly change, and we know that demand will continue to rise upwards to the I don't see the collaboration changing. We may have more traffic, more need, more different applications running, but I would anticipate in the next 1 to 3 years, many of the networks that are part of our Quilt and our regional collaborations look to CENIC as a leader in the country in advanced networking. I don't expect that'll change the next 1 to 3 years, and I expect that our collaborations will stay the same, and we can still work together, support one another in the new technology implementations.
So one of the things you may have noticed from the map that I showed is that we have a number of sites, DOE sites, that we connect that are in California. And they collaborate with a number of your schools and colleges and universities. So there's a lot of collaboration that's already happening within California. And so we envision that our work with CENIC is only going to increase. We're only going to have a closer partnership with CENIC as time goes on, because our researchers and your researchers need to collaborate, and CENIC and ESnet are going to be the ways in which that's going to happen.
Well, Dave, you're part of the family. I mean, you're our layer 1 through 3 NOC. You know, I look going forward 2 to 3 years. The efforts with, and they're already underway. The work we're working with you all on, Brian Court's here, in reaching more of the medical and clinical research hospitals. I think that relationship is going to grow. And then as I inferred in my presentation, the development of tool sets, new networking tool sets and databases that benefit the community. I think in the next 2 or 3 years, we're going to see a lot of that activity taking place as the needs arise.
Yeah, any questions?
So there was a great set of slides. Question, you said you already, you've been deploying this 100 gig network. What exactly the utilization, bandwidth utilization do you have right now?
So there's a great, again, I have to imagine it. As you walk into the ESnet office, there's a huge screen and it has a map on it. But you can also get this on the web. There's a nice weather map of the ESnet network, and it shows the 100 gig links on it. And right now, the utilization is pretty much around, at any given time, if you go on there, you're going to find a utilization that's going to be around 10 gig across any 100 gig link, usually. You will find cases where, particularly around Fermi, where you've got a lot of LHC1 or a lot of LHC data, and LHC1 is the overlay network that we also work with that connects a number of the LHC sites. You'll find a lot of that data transferring, so you'll start to find the network starts to spike up into the 40 and 50 gigabits per second range in some cases. So we do find, in certain areas, we do find the 100 gig, we actually do need it, and it actually is being used. We've also, when we're doing acceptance testing, we manage to do loop testing, so we actually max them out at 100 gigs, so we actually know they can do it.
Any other questions? Well, with that, I'd like to thank our panelists. Thank you very much. And thank you for the absolutely stunning slides.
Yeah.
All three of you.
They were beautiful.
We'll email
Yeah.
it to you.